working on a new transfer mechanism for fonts. And then, so maybe just to start, I'll give a little bit of like justification for why this is something that we're working on. A really good example is with things like CJK fonts. So that's Chinese, Japanese, and Korean. So these are fonts that have, over, could be, as much as like say 60,000 characters in a font. And so when you're using you want to use these web fonts on your page, typically most pages maybe only need say 1,000 of those characters at any given time. So kind of the really naive way to approach this is to just load the whole font, which is probably several megabytes, but you only actually use some small part of it. So this is quite wasteful. And so there has been some attempts to solve this over the years. The most notable one is Unicode Range, where you can segment a font up into some different subsets. So just pieces that have less than the full set of characters. And then the Unicode Range mechanism allows you to download just those pieces that you need. So this certainly is better than kind of just sending the whole font, but it's still not ideal. It still usually ends up sending way more than you need. And there's also a lot of issues that come up when there's interactions between characters that are in different subsets, since those no longer work. So in some scripts like say Arabic, there's a lot of interactions between characters, so you can't break those characters up into different subsets. So incremental font transfer is an attempt to kind of solve this problem kind of really well. And so the general idea of how it works is you leave the font as one full complete unit, and then your client loads parts of the font. So you have a page, you have some characters, you load just the characters needed for that page. And then when you go to say another page or see new content, you can patch in more data from that font. So this allows you to grab just what you need at any given time, and it keeps all of those inter-character interactions intact, so the font works exactly the way it's supposed to. And so maybe before diving into the kind of a bit more of the details of what we're actually doing in the spec, I can give a quick, we have a demo that we built in WebAssembly of this kind of working in a browser. So I'll do a quick demo of that just to show how that's going to work. So just give me 1 second to get this presented. There we go. Okay, all right. So what this demo does is it just goes through a few different pages of content. It loads the fonts needed to show that content using both the incremental transfer and then the Unicode Range approach that I talked about. And then it shows you a comparison of how much data each one loaded. And this is actually loading the font from the server. It's patching it in and creating font. So this is working exactly like it would kind of in a real implementation. And as I mentioned, this was all just built in WebAssembly. Okay, so we can go to the first page here. So we can see so Unicode Range grabbed a font file that was 32 kilobytes. Incremental transfer grabbed 11 kilobytes worth of fonts, and you can actually see here in the Inspect tab, these are the incremental requests. So there's 2 fonts on here, both about 5 kilobytes of data were loaded for those. Okay, and then so I went to another page. So this introduces a few characters that weren't in that last subset that were grabbed. So you can see incremental transfer now sent out a couple much smaller requests just to add in that extra data that's missing. Whereas something like Unicode Range here, since it already kind of grabbed one big subset, didn't do anything. And then we can kind of carry on, and it can grab, it'll grab additional data as you get new things. And then now we hit a new language. And so Unicode Range, since this is needed a new subset, grabbed a whole new subset, whereas incremental transfer just patched in a small amount of data to add all of these accented characters. And then same with Cyrillic. Here's the next one. Yeah, so this button here allows me to toggle between displaying the font, both with the font built from the patch and the font built from Unicode Range. And there's something this demonstrates a little interesting thing, and this touches on the problem I mentioned about inter-character interactions. So if you look at the period and the Y character in the title here, you'll notice that when we go to Unicode Range, things are shifting around. And that's because the Cyrillic characters are in a different subset than the Latin characters with Unicode Range. So the kerning rules between those characters don't work. Whereas with incremental transfer, we've managed to retain them. And so we get the proper kerning. Okay, now we can move on to something much harder, and this is Chinese. And so here we can see this is using our production Unicode Range solution that we use on Google Fonts. And you can see, just for this small amount of text, it's grabbed, I think, about 600 or 700 kilobytes of data just to show this. Whereas with incremental transfer, we're able to grab a much smaller amount. And then this gets worse as we introduce new characters, whereas incremental transfer is able to easily patch in small amounts. Okay, and then the last one, we think another really interesting application for this is with emoji. So there are lots of emoji, and in any given context, you probably only need a small handful of them. So with incremental transfer, we can grab just the emojis that we need for any given situation instead of grabbing the entire font, which, as you can see from the Unicode Range side, is quite large. Okay, so that's that's it for the demo here. So I'll just close that out. And then, okay, so let's talk about what's actually going on under the hood here, what the specification kind of is specifying. So the specification actually gives two different methods for doing incremental transfer. And so maybe first off, I'll talk about why we have two. So the first method, which we call patch subset, was shown through simulations and stuff to be pretty much as far as in terms of how much data it's transferring is superior to the other method, but it has a pretty significant downside in that it requires a fairly intelligent server to be run. So if you're somebody who's just running your content on a CDN and you can't have them run a complicated server for you, this sort of option is not going to work, even though it's more efficient. So then we're also including a second method, range requests, which the server side just needs to be any old HTTP server that supports range requests for it to all work, and it won't be as efficient as the first one, but at least it will give options for people to use this technology, if they're restricted in what they can do. Okay, so then I probably should talk about the two methods, and I think I see Miles on here, so he can probably talk about range requests after me if he's up for it. Okay, so yeah, you're okay, great. So the first method, the kind of the more efficient one, is patch subset. And so how this works is the client sends a request that says, okay, I've got a font that has these specific code points in it, and I need it to also cover these additional code points. And then the server side, kind of in real time, will create two subsets of the font, one at the state the client is currently at, and one at the state where they want to be. Then we'll generate a binary patch, in this case using shared Brotli, and then send that to the client. And then the client will apply that to their font, and that will upgrade their font to that extended subset. So that's the gist of how that works. And then Miles, if you want to, you can talk about range